Hello everyone, welcome back to my class, and in this class we're going to discuss on the topic growth and depreciation of chapter 2 compound interest of class 9 ICSE board. Now after completing this class you should be able to identify the initial amount and the final amount given in the problem, and you should also be able to identify which formula you're going to use for problems based on growth and problems based on depreciation. If you have seen my previous class videos on this chapter, you will understand that the final amount is always greater than the original amount. That's the principle. And the formula to find the amount is A equals to P into 1 plus R by 100 whole power N, where the terms have their usual meanings. Now if I ask you to list some properties people hold whose value increases over time, you may go across the properties you hold at your home. Now, you may come across properties like necklace and rings made of diamond, gold, platinum, silver, and more, because of their high demand in the market. You can also find properties like houses and apartments, a plot of land. Now if you come across more examples, you may let me know in the comment section below. Now this type of properties brings you more price when you sell it compared to what you have paid when you buy it. That means the final price is always greater here than the initial price. The final price is denoted by V and the initial price is denoted by V0. That's the original price. So this properties gets you a higher return and profit when you sell it. And the formula you're going to apply in cases like this is V equals to V0 into 1 plus R by 100 whole power N, which is same like that of the amount equals to principal into 1 plus R by 100 whole power N. Now, the original amount is denoted by V0 and the final amount is V. In contrast to the properties we have just discussed, most of the properties that we see in our daily life, the values decreases over time. Now again, listing those properties, we have like automobiles, like cars, motorbikes, and buses, and many more. Then we have electronic gadgets, like mobiles, computers, and many more gadgets at your home. Now this type of properties, their value decreases over time, and which means the final price is always less than the original price. That means you're going to end up getting less amount when you sell them second hand to another person, and hence the original amount is always greater than the final amount, and that is why we have a minus sign in the same formula we have for the previous properties. So V equals to V0 into 1 minus R by 100 whole power N. Now let us see this formula in detail. In case of growth, we have V equals to V0 into 1 plus R by 100 whole power N when N is 1. Okay, this is same like the formula we have for compound interest, amount equals to principal into 1 plus R by 100 whole power N. Now here, if you open the bracket, you will get V0 or V original amount plus this value, Okay, now what you are going to do is you are going to add something to the original amount so that you get the final amount, and hence V is greater than V naught. And if you see, if we increase the power, say n equals to 2, then applying the expansion a plus b whole square, we get this value, and again opening the bracket, you get the original amount along with this term. Now again you are adding some amount to the original amount to get the final amount, and hence we have the final amount is larger than the original amount. Now in case of depreciation, V equals to V naught 1 minus R by 100 whole power 1 when n equals to 1. So what we are doing actually is, if you open the bracket, you get the original amount minus this amount, and hence the original amount seems to be larger than the final amount. In the previous case, the final amount is larger, and here the original amount is larger, which holds true for other powers also. Now let us solve some questions from the exercise 2.3. Question number 1 says the present population is 2 lakh. So the present population is given, and the rate of interest rate of growth, that's growth problem. Okay, rate of growth is given 10% and 15% for the 2 years. First year it's 10% and the second year it's 15%, and time is 2 years. Now remember, this is the case of growth. So what's the formula? The formula is we are going to have V equals to V naught into 1 plus R by 100 whole power n. Now since we have two rate of interest, so R1 and R2, remember the formula we have seen the last class. Okay, the thing is we are going to find the population after 2 years, and obviously since it is a growth problem, after 2 years the population will be larger than the population what we have now, and hence we have the final amount is larger than the initial amount. So the population we're going to find is V, and the given population is V naught. So what we have 2 lakhs is V, the original population. Okay, now just putting the values, we have 2 lakh into 1 plus 10 by 100, 1 plus 15 by 100. That's 2 lakh into, if you cancel this you get 11 by 10, and you get 23 by 20, 5 3 times and 5 20, so you get 23 by 20. Now on solving this you get 2 lakhs 53,000. Now that's the population after 2 years, and hence the increase in population is, the final population is this 2,53,000 minus 2 lakhs, so that's 53,000. In this question we have the present population of a city 67,60,000. Okay, so that's given, and it's the case of growth problem. Increases, rate of growth is given 4% per annum, and we have to find the population after 2 years, hence means after, and also before 2 years, ago means before. Okay, so we have two cases here, 2 years hence and 2 years ago. Now the problem is based on growth. Okay, so the formula is going to be the same, growth formula. Okay, we have to find out whether the given population is V naught or V. Okay, so the given population, we have to find out whether it is the original population or the final population in both the cases. Okay, so in the first case we have to find the population after 2 years, and we know it's a growth one, so after 2 years the population is going to be more, and we know in growth cases the final amount is more than the original amount, and hence since this is lesser than the final one, so this becomes the original population. But in the second case where we have to find the population 2 years before, that means the population was lower than what we have today, and hence this is more, and this is the final population of the city. So now just when we have decided whether it is V naught or V, we can now put the values in the formula. Okay, so time is given 2 years. Now just putting the values, 67,60,000, 4 zeros. Okay, 1 plus 4 by 100 whole power 2. Now that means we are having 2 times 67,60,000, that's 100, 4 by 100, 2 times 4 zeros you can cancel, and if you multiply you get 73,11,660. Okay, that's the population after 2 years. So 73,11,660. In the second case, putting the value, since this is the final population and the population before 2 years we don't know, you have to find out. So now here V is 67,60,000, and V naught we are going to find 1 plus. So it's basically the same formula with the same values, only thing changed is V naught and V, and we have this equals to V naught 104 by 100 power 2. Now we shift and we get V naught equals to 67,60,000. Now the numerator comes here, this goes 425 and 426. So what we have is 26 into 26 is 676, so that we can cancel, and we have 1000, 10,000 actually, 10,000 into 25 into 25, so that's 625 and 4 zeros, so 62,50,000. So the population before 2 years was 62,50,000. In this question we have the property value decreasing, so this is a different one, depreciating problem. Okay, so we have a different formula. Rate of depreciation is given 5%, so given, and the present value is given 4,11,540. What was the value 3 years ago? Now here, in case of depreciating problem, we have the original amount is more than the final amount. Okay, so the final amount is going to be lesser. So you should not be confused. You just have to find out which one is less here, the final one. Okay, and hence this is the final population. So we have V equals to this. Now the initial one was more. We just put the values now. For like 11,540 equals to V naught into 1 minus 5 by 100. For like 11,540 equals to V naught, 5 goes 20 times, so 20 minus 1, we have 19 by 20. Okay. And the time is 3 years, so 3 times. V original equals to 4 like 11,540 into 20 into 20 into 20 divided by 19 3 times. So after calculating you get 4,80,000. So the value of the property 3 years ago was 4,80,000, which is more than the current price. In this question, the factory increased its production of cars from 80,000 to 92,610. Now you need to find out the time. The production of the cars 2011 and 2012. In this year was 80,000, and in the year 2014 and 15, that's 92,610. At the time 2011 to 2014, we have 3 years. That's the 3 years gap. Okay, so n is 3, and rate of growth we need to find out. This is a growth problem again. So we have the formula for the growth problem. We just need to find out which one. We know that in growth problem we have the final amount is more than the initial amount. Obviously this has to be that the final amount. So final amount is 92,610, and the initial actually this is production of cars, number of cars. Okay, so the initial number of cars will be this. Okay, so now just putting the values in the formula. So putting the values in the formula, we get 92,610 equals to 80,000 into 1 plus r, we need to find whole power 3. So that's 92,610 divided by 80,000 equals to 1 plus r by 100 whole power 3. Since the right hand side is a cube, so the left hand side has to be cube of something. Okay, so after calculating we get 9261 is cube of 21, and 8,000 now is the cube of 20. So we get 21 by 20 whole cube equals to 1 plus r by 100 whole cube. Now since the powers are same, now we can equate the bases. So we have 21 by 20 equals to 1 plus r by 100. So 1 we can shift the other side. So r by 100 equals to 21 by 20. 1 goes to that side, we have minus 1. So that's, if you take LCM, you get 20, and 21 minus 20 we get 1. So r by 100 equals to 1 by 20. So r equals to 100 by 20, that's 5. Okay, so we get rate of growth of the production of cars in the company or the factory. We have 5% per annum. Okay, now in this question we have both growth problem and depreciation problem. So here we can see Turani bought a plot of land and the cost of the plot of land is given. So this is a case of land. Price of the land is 1,80,000 and the present price of the car is given 3,20,000. Okay, the value of the plot of land grows uniformly, so grows uniformly at the rate of 30% per annum. So this is a growth problem. A rate of growth is given 30% per annum. Okay, while the value of the car decreases or depreciates by 20% in the first year and by 15% per annum thereafter. So we have 3 years, right? Time is given 3 years. So for the first year, the rate of depreciation in case of car we have 20% per annum, and then for the successive 2 years we have 15% for the other 2 years. Okay, so this is a growth problem, so we use the growth formula, and this one is the depreciation problem, so we have the depreciation formula. Now we have different rates. The case of land is a growth problem. Okay, so we need to find out whether the present price is V0 or V. Now after 3 years the price has to increase, so that means this should be the initial price. This is V0, and putting the values we calculate the final price of the plot of land. We get 1,80,000. 1 plus, and R is given 30 by 100 and power 3. So we get 1,80,000. That's 13 by 10, 3 times. We get 3 zeros we can cancel, and we get that's 3,95,460. So that's the final price. After 3 years we get rupees 3,95,460. So that's the price Mr. Durrani gets after selling the car. After selling the plot of land after 3 years. Now the price of the car goes on decreasing, so the original amount is more. The original price is more than the final price. So here the price given, present price, will be the original price. Okay, so this is V0. Okay, so putting the values we get, this is 3,20,000. Okay, 1 minus the first year, the rate of depreciation is 20 by 100. Then we have 15 for the successive 2 years. That's 3,20,000. And 20 goes 5 times, so we have 5 minus 1, 4 by 5, and here we have 100 minus 15, 85. That's 17 by 20 and 17 by 20. Now on calculation we get 5 into 2, 20, 20, this 2 zeros I can cancel, and then again 5 into 2, one more 0, and 2 goes 160 times. So 160 into 4 into 17 into 17. So that's rupees 1,84,960. So 1,84,960 is the price of the car after 3 years. Now to find out the total profit or loss, we need to find the total cost price. So the initial cost price of the land is 1,80,000 and the car is 3,20,000, which comes to, if you add it, you get 5 lakhs rupees. 5 lakhs. Okay, so that's the total cost price of the two properties. Now the selling price of both the properties. So in case of land, the selling price has gone up, that's 3,95,460, and the selling price of the car has gone down, 1,84,960. You get rupees 5,80,420 rupees. Okay, so the total cost price is actually less than the total selling price. So Mr. Durrani has a profit. So profit equals to 5,80,400. Sorry. 5,80,420 minus 5 lakhs. So that's 80,420 rupees is the profits when he sells both the properties. That's all for now in this class. I hope you understood the topic, and if you get confused, you can go back and play the video again, and you will know how to solve the problem. See you in the next class.